Hello, everyone. I'm Frank Levax, the editor-in-chief of Jack Composite magazine. We're here today to talk about a really interesting project called Zebra, standing for Zero Waste Blade Research. Composites are mandatory in renewable energies and particularly in wind energy. Zebra's aim is to push the boundaries of recycling in this field. This project is driven by the French research center IRT Jules Verne and involves many partners, including very big companies. Arkema, CANOE, ENGIE, LM Wind Power, Owens Corning and Suez. Céline Largeau, the Zebra project manager, kindly accepted to answer to our questions. Hello, Céline.
Hello.
So my first question will be about yourself. Can you introduce yourself briefly?
Yes, hello, I'm Céline Largeau. I'm project manager and also responsible of renewable energy sector at IRT Jules Verne. I am a mechanical engineer. Before joining IRT Jules Verne, I spent 15 years in automotive industry and more particularly in Renault Group. And now my job in IRT is to support our project within the IRT Jules Verne, both with the internal teams and with the partners involved in the project. And I'm also in charge of developing renewable energy sector within the institute, IRT Jules Verne.
Okay, so a lot of offshore activities in the future, I hope. How the Zebra project was born, and I would like also know a bit more about the context and how all the partners met.
The discussion started many years ago, in 2016, some discussion with some partners involved in the project. But the Zebra project really started in 2020, beginning of 2020, and initiated by Arkema, Owens Corning, ENGIE, and LM Wind Power. And the project started in September 2020 with a key player that we have in the project. That means 5 industrial big players. So
Yes.
Arkema, Owens Corning, LM Wind Power, ENGIE, Suez, and also 2 technical centers, CANOE and the Institute IRT Jules Verne.
Yeah, so you have all the spectrum from the research center to really, even not the end user, but the energy management side.
Yeah. It's a project with the involvement of industrial key players. So we have the entire supply chain and the entire know-how and expertise in the project to reach our objectives. So it's a very important and powerful consortium.
Yeah, it's quite unique.
It's quite unique, yes.
Yeah. Okay, so recently, the first full-scale blade of this project was made and released in Denmark. So maybe you can say a bit more about that, and also what were the most important milestones in the project, and what is needed to be done to achieve the project also.
The first major milestone was the manufacturing of this first blade. So we achieved the first milestone. Now the blade is entering in a full-scale structural lifetime testing in Denmark, in LM Wind Power facility, to verify the performance of the composite and the material used in the blade, and verify the feasibility for future sustainable blade production. And once these tests are finished, we will work on the end-of-life recycling method, and we will validate, of course, this method. And so this is the next big milestone is the dismantling of this first blade and also the validation of the recycling methods to verify and to validate that we made the challenge of bringing the wind energy sector into the circular economy loop in a sustainable manner according to the principle of eco-design.
You didn't mention it. How long is the blade? It's a huge one. I saw some pictures on.
Yes, difficult to take a picture when you are at the roots section, but yeah, it's 62 meter long, so it's a full-scale blade, a beautiful full-scale blade.
Yeah, quite impressive to be just beside this kind of object all the
Yeah.
time when you visit a wood blade manufacturing site. So at a technical level, what was the most difficult thing to achieve for this project?
In fact, we have the chance to have all the know-how, expertise, and specialists in the project. So the partners made very good preparation before doing the infusion of the first blade. So we performed numerous of different tests at different level, coupon level, subcomponent level. So we de-risked a lot at this different scale. So we were quite confident for the infusion of the long blade, and we benefit from huge experience from LM Wind Power in infusion, more than 30 years of infusion experience. And we have also the chance to work with the Arkema and Owens Corning products with high quality and high performance materials, and a lot of expertise and specialists in Arkema and Owens Corning. So the challenge was high, but we have all the people in place to reach the objective, and we did. So that was very, very good.
Yeah. And how many people were involved in the project as a whole? You have an idea?
I don't have any idea, but yeah, quite a lot, because of course you have all the operator in LM Win. We perform the infusion of the first blade. We have a lot of people in LM on the R&D center working on the project, and in every part. I didn't make the count of how many people work on the project, but it's quite a lot. Anyway, I will do the calculation.
The math, yeah. Maybe 100, 100.
Maybe not full time, but could be something like that. Yes.
Yeah, for such big projects, in average it can be that big.
Yeah.
So the main goal is recycling for this project. So have you already some products in mind that can be made from the recycled blade at the end of life of it?
Yeah, what is very specific in this project is that we use a thermoplastic resin. And we have also people in the project like CANOE and Arkema working on the development of new recycling methods like dissolution and cracking. And it allows us to separate the helium resin from the reinforcement glass fiber. And that means that we can reformulate the helium resin to use it again in a new blade. And we can also remelt or reuse the glass fiber. So we can address circular economy, making a new blade with this recycled material, but also other application like automotive industry, which is looking for recycled material. So yeah, we have some application in mind.
Yeah. Maybe you could say a bit more about the resin from Arkema used in this project, the helium one, because it's more and more known, but newcomers still don't know, because you talk about infusion and thermoplastic. So I know what it is, but please explain to our audience the behavior during the manufacturing and at the end of the resin.
Yeah, the goal was not to develop new processes, new tools. So what is good and very important with this helium resin is that you can use it as a thermoset resin and with some adaptation, but quite low. And so it allows to use a standard infusion process with this kind of resin. This is a good. What is important for the economic performance of the project. And also to avoid developing new tools.
Yeah. So to be simple, you start with a thermoset resin and you end up with a thermoplastic at the end of the process, right?
We start with all the process is done with helium.
Yes, but the behavior of the resin at first is a thermoset one, and once it's done, it's a thermoplastic.
Yeah, exactly. Sorry, yes.
Kind of the best of both worlds.
Yes, both. Yes, exactly. Combine the best of the both.
Yeah. As I mentioned, it's really known nowadays, but it's all the time better to explain to newcomers. So one of the final questions from my side will be the outcomes of the project in terms of business. How do you think the footprint of this kind of technology could be?
What we see is that we have key players in the project, like Arkema, like Owens Corning, like ENGIE. So, of course, when you have such key player, industrial player in project, you can imagine that the importance for them of this project. It's a 18.5 million euro project, so it's quite big, and for sure there is a huge potential business at the end of the project.
Yeah. And all the time it depends of how they will share the know-how after that. Yeah. So thank you, Céline, for sharing your insight. Do you have anything to add before we leave each other?
Yeah, something also interesting is that this project started and was started during 2020 year. It was not an easy year because of COVID, in this sanitary situation. So we only met one time. It was in February in Ponferrada with the first blade delivery, and it was the first time we met each other in face to face. So it's usually, it's a crazy challenge, but we managed to work very closely together. We have every day we have meeting together. We have a lot of interaction in the consortium. It's a very collaborative consortium, and it works, and it's nice. It was very good to meet each other. We hope that we'll be able to meet again, and more. I think in GAC we will meet each other again. But I think something it has to be noticed, the fact that in 1 year and a half, we only met one time.
Yeah, and you will make a presentation during the JEC World about the Zebra project, right?
Yeah, on the 4th afternoon, yeah.
Okay, so see you there.
Yes, you will.
So thank you all for watching, and thank you again, Céline. It was nice discussing the project with you, and I hope our audience will take advantage of it.
Thank you very much.
Thank you, Céline. Bye-bye.
Bye-bye.